Over the course of the next few videos, we're going to actually run through an entire great circle problem. Starting with this one, just doing the distance. So our problem will be departing from 19 degrees, 20 minutes north, 070 degrees, 45 minutes west, and arriving at 30 degrees, 15 minutes north, 021 degrees, 0 minutes east. I just made these numbers up right now. This is probably approximately just outside of the Caribbean. This very well might be like inside the interior of Africa. This might be in Mauritania for all I know. But we're going to be sailing from there to there. Step one is to find the distance, to actually see how effective using a great circle route will be as opposed to just a normal Mercator sailing. I don't really want, or before we even do that though, we need the starting values. So like I said before, we cannot work in degrees and minutes, and we can't work in minutes alone. We have to convert this all to the degrees. So the very first thing we do before we go any further is we just convert the two latitudes to degrees, calculate the difference of longitude, and convert it to degrees. So to begin that, we'll just say off to the side here, L1, L2, and DLO. After I convert these, if you remember from the lists of waypoints or the lists of formulas we had before, we'll be using L1 a lot. We'll be using DLO a lot. We'll be using C a lot and LV a lot. For that reason, it's very worthwhile to have a calculator that can save multiple variables onto its memory. So you don't have to type out the full value every time. You can just pull up X or Y or A or whatever you need and then throw it right in. I would be doing you a disservice, and I'd be kind of shaming the memory of the man who helped me perfect my cell nav ability if I didn't point out that according to him, the best calculator you could ever use is not this. He was actually upset with me that I didn't buy one. It is the Casio FX 300 ES Plus. If you asked him, no mariner should ever use anything other than the Casio FX 300 ES Plus. So ignore my Texas Instrument blasphemy. Ignore that. Just go with the Casio FX 300 ES Plus. This still works relatively well for me. I've gotten used to it, and I'm happy with it on its own. Now, we'll do L1 here. So L1 is 19 degrees, 20 minutes north. So we already know this is 19 point something. Well, 20 is 1/3 of 60. So you just do 20 divided by 60, 0.33 repeating because it's 1/3, obviously, degrees. Now what we're going to do is we're going to add 19 to that. So now we have 19.3 degrees repeating. I'm going to store this in my memory. The way you do it on the TI-36 is you press store and then pick a variable. So I'll just pick X because it's the first one. There. And then if I were to ever tap X, it would come out automatically. So then after I do that, I'm going to mark to the side that L1 equals X. So that whenever I use the calculator, I can just pull that off automatically. L2 is 30 degrees, 15 minutes. So again, 30 degrees, 15, it's going to be 0.25, but 15 divided by 60, 0.25, add 30, store Y. So now this one is Y, 30.25 degrees, and that is equal to Y. DLO, well, to do that, we actually have to find the difference in longitude between the two. So let's just really quickly 070 degrees 45 minutes, 021 degrees 00 minutes. Remember, this is west and this is east. So to find the difference between the two, we don't subtract, we add them together. So you get 0.91 degrees, 45 minutes. And it's not west or east, it's a difference of longitude. So then you do 45 divided by 60 plus 91. So our DLO is 91.75 degrees. You hit store. My next option is Z, so that is now Z. So now we have all of the starting variables saved and ready to use, and we can actually begin our formula. So again, cosine of distance is equal to the sine of L1 times the sine of L2 plus the cosine of L1 times the cosine of L2 times the cosine of the difference of longitude. And remember, just to going back on this, if this was south instead of north, if we were going to the southern hemisphere and not keeping everything in the north, then I would always label L2 as a negative number. I would always, when I write it into the equation, I would add a little negative sign before every time I write L2, so that the calculator actually knows to work it off that way. The formula will only work if I apply that. We're only in the north right now, so we're not going to do it. So I'll write out cosine of D is equal to the sine of 19.3, because that is L1, times the sine of 30.25, because that is L2, plus the cosine of L1, so 19.3, times the cosine of 30.25, times the cosine of 91.75. And that is our first equation. So now we'll actually put that together. Some people want to do it in one round, and they do this in parentheses plus that in parentheses all together in a single calculation. They always inevitably mess something up. Break it up into parts. Just do this. Then if your calculator has the ability to refer back to previous answers, some calculators don't. If they don't, then I guess you have to do it all in one go. But I'm going to do just this, then add them together, then do in cosine inverse at the end. Because remember, I could also rewrite cosine of D is equal to this as D is equal to cosine inverse of all of that. They're equally true. I prefer writing it the other way. It just helps me keep things organized in my mind, but you can do this if you want. So we're going to start with sine of L1 times sine of L2. Remember, L1 is X, L2 is Y. So we do sine of X times sine of Y. Put it in. There's our answer. Now I'm just going to hang on to this, and I'm going to put these through. So cosine of X, cosine of Y, cosine of Z. Cosine X, cosine Y, cosine Z. There we go. You're supposed to add the two together. So I'm going to do plus, bring this back. That is all of this. Then you do inverse cosine of our answer. Inverse cosine answer, 81.1, or 81.8. So D is equal to 81.8. What is this? It's not miles. That wouldn't make any sense. Think about how far we're going. We're going from the Caribbean to Africa. This is written in degrees. This is 81.8 degrees of difference. We have to convert that because this is not useful to us. So we do times 60, and our distance is equal to 4,910.57 nautical miles. That is the total distance it will take to sail from our starting point to our ending point following the Great Circle sailing. The reason we do this distance formula is because if you went back and you took these same 2 points and put in a Mercator sailing, I'm not going to do it because I don't want to, because I really, really don't want to do the extra work here. But if we were to do it based on a Mercator, I would bet you we would get something like 5,250 miles, something like that. A good at least 300 miles. Wait, that's probably too much. It might just be 5,000 miles. Yeah, I think it's probably more like 5,000 miles. If we were crossing the Pacific, then that would be an additional 300 miles on your sailing because the Pacific is so much larger. Crossing the Atlantic, it's not that extreme. It would probably be an additional 80, 90, 100 miles. Not extremely huge, but that is another day or two of sailing. So why have that? Why add it? If you're on a schedule, if you're moving cargo, obviously you can't just add a day when you could have sailed for less time by following a great circle. So that's why the distance formula is important.